GeopByte.
Now, let us start exercise number 1.4. In that, first question is evaluate each of the following. Below we have few questions. Let us solve them one by one. If you see a bit minus 30 divided by 10. We can also write this minus 30 divided by 10. Now, we need to solve this. 10 ones are 10, 10 ones are 10, 10 threes are 30, right? 10 ones are 10, 10 threes are 30. We can write minus 3 by 1. Now, minus 3 by 1. 3 by 1 is 3, minus 3. Answer is minus 3. We got a negative integer. Means here we have only one minus sign, that is odd number of minus sign. We got answer in negative integer. If you see B bit, we can write 50 divided by minus 5 as like this. 50 divided by minus 5. Now let us solve. 5 ones are 5. 5 tens are 50. We got 10 by minus 1. 10 divided by 1 is 10. As we have minus, answer is minus 10. We got negative integer here as we have single minus. Now, if you see C bit, we have minus 36 divided by minus 9. We can write this minus 36 divided by minus 9. If you see, in division, when there is a minus sign in numerator and denominator, they both get cancelled. The leftover numbers are 36 by 9, 9 ones are 9, 9 fours are 36. 4 by 1, that is 4 is the answer. We got positive integer as answer as we have two minus signs in division. Similarly, in multiplication also, we will have the same rule. Now, let us see D bit, that is minus 49 divided by minus 49. We can write like this. Right? Now we have two minus signs in numerator and denominator. Let us cancel. We have 49 by 49. 49 ones are 49 ones are. 1 by 1 is 1. Right? We got positive integer. Now let us see three more questions in the same question. We have E bit as 13 divided by minus 2 plus 1 in the brackets. As per BODMAS rule, we have to solve the numbers first which are in the brackets. If you see 13 divided by, we have minus 2 plus 1. If we solve the numbers in the brackets, that is minus into plus minus. 2 minus 1, 1. But the sign for the greater number is minus. It is minus 1. Now, we got this 13 divided by minus 1. We can write this 13 divided by minus 1. Right? Now, 13 by 1 is 13. We have minus sign, that is minus 13. Now, let us see F bit. We have 0 by minus 12. We can write it like this. If we have 0 in the numerator, while division, if we have 0 in the numerator, the answer is 0. Whatever may be the number in the denominator, the answer is 0. If we see G bit, we have minus 31 divided by minus 30 plus of minus 1 in the brackets. Now, First, as per BODMAS rule, we have to solve the numbers which are in the brackets. Minus 31 divided by, first let us write as it is. Now, minus 31 divided by minus 30 plus into minus 1. That is, write minus 30 as it is plus into minus 1. Now, minus 31 divided by minus 30 minus 1. Minus into minus plus 30 plus 1, 31. Sign remains minus 31. Minus 31 divided by minus 31. That is, we can write like this. Minus gets cancelled. 31 gets cancelled. The answer is 1. Now, let us solve the last two bits in this question. We have h bit as minus 36 divided by 12 in brackets divided by 3. As per BODMAS rule, we have to solve the integers or numbers which are in the brackets first. So, minus 36 divided by 12 divided by 3. Now, we can write this minus 36 by 12 divided by 3. Write as it is. This can be written like this. Now, 12 ones are 12. 12 threes are 36. Right? Now, we have minus 3 by 1 divided by 3. Now, 3 by 1 is 3. We have minus sign, that is minus 3 divided by 3. We can write this minus 3 by 3, that is 3 ones, minus 1 by 1 is minus 1. Now, let us see I bit. In this, we have minus 6 plus 5 in brackets divided by minus 2 plus 1 in brackets. As you know, as per BODMAS rule, we will solve the numbers which are in the brackets first. Minus 6 plus 5 divided by minus 2 plus 1. This is they have given. I have removed these brackets and written. Now, minus into plus, minus into plus minus, 6 minus 5 is 1. We get this minus as we have minus for the greater number. Now, divided by, here if you see, we have minus 2 plus 1. Minus into plus, minus as we have minus sign for the greater number. Right? Minus into plus minus, 2 minus 1 is 1. Minus 1 divided by minus 1, we can write it like this. Minus gets cancelled. 1 also gets cancelled. 1 by 1 is 1. Now, let us see second question. Verify that A divided by B plus C is not equal to A divided by B plus A divided by C for each of the following values of A, B and C. They asked to verify that LHS should not be equal to RHS by giving A, B, C values. Let us see the first bit, that is A bit. We have A is equal to 12, B is equal to minus 4, C is equal to 2. Now, let us take the given condition, that is A divided by B plus C is not equal to A divided by B plus A divided by C. Now, let us consider LHS condition. That is, we have A divided by B plus C. Now, we will substitute the values in this condition. We have A as 12, B as minus 4, plus C as 2. 12 divided by, as per BODMAS rule, we need to solve the numbers or integers which are in brackets first. That is, we have minus 4 plus 2. Minus into plus, minus 4 minus 2 is 2. We have minus sign for the greater number, that is minus 2. Right? Now we have 12 by minus 2. We can also write 12 divided by minus 2. 2 ones are 2. 2 6 are 12. We have 6 by minus 1. 6 by 1 is 6. We have minus sign, that is minus 6. We got LHS as minus 6. Now let us solve RHS. We have RHS, that is A divided by B plus A divided by C. Now we will substitute these numbers. A is 12 divided by B is minus 4 plus A we have 12, C as 2. Now we can write these numbers. 12 by minus 4 plus 12 by 2. Right? Division, we have division sign. 12 by minus 4 plus 12 by 2. Now 4 ones are 4. 4 threes are 12. We have 3 by minus 1. 3 by 1 is 3. We have minus, that is minus 3. Plus 12 by 2, that is 2 ones are 2. 2 6 are 12. 6 by 1 is 6. Minus into plus, minus 6 minus 3, 3. That is, we have plus for the greater number. We got plus 3. RHS is equal to 3. We got LHS as minus 6 and RHS as 3. We verified that LHS is not equal to RHS. Now we will verify in the B bit. That is, we have A is equal to minus 10, B is equal to 1, C is equal to 1. Let us take this condition. A divided by B plus C is not equal to A divided by B plus A divided by C. Let us consider LHS condition. We have LHS that A divided by B plus C. We have A as minus 10 divided by B as 1 plus C as 1. Now we have substituted the values. Let us solve. 1 plus 1, 2. So we can write like this. Now minus 10 by 2. 2 ones are 2. 2 fives are 10. We got minus 5 by 1. That is, 5 by 1 is 5. We have minus sign. So LHS we got as minus 5. Now let us solve RHS. We have A divided by B plus A divided by C. Now we will solve these numbers. Minus 10 divided by B is 1 plus minus 10 divided by C as 1. Now let us solve. We can write this minus 10 by 1 plus minus 10 by 1. Right? We have minus 10 divided by 1. Minus 10 divided by 1. We can write like this. Now we got 10 by 1 is 10. We have minus sign, that is minus 10 plus same. We have 10 by 1, 10. We have minus sign, minus 10. Now Write minus 10 as it is. Plus into minus. Minus 10. Now we got minus 10 minus 10. Minus into minus plus 10 plus 10, 20. The sign remains minus. That is, we got RHS as minus 20. If you see, we got LHS as minus 5 and RHS as minus 20. We verified that LHS is not equal to RHS in these both conditions. Now, let us see third question. Fill in the blanks. Below, we have some questions and missing blanks. Let us find them. We have a bit as 369 divided by dash is equal to 369. Let us assume this missing integer as x. 369 divided by x is equal to 369. Now, 369, this dividend x, when it goes to the right hand side, it gets multiplied with the number 369, that is equal to 369 into x. When this dividend x goes from left hand side to right hand side, it gets multiplied with the number 369. Now, we have to find x. So, this 369 will come to the left hand side. That is 369 by 369. As it is in product with x, when it comes to the left hand side, it gets divided with the number 369. We have x on the right hand side. These both gets cancelled. X is equal to 1. As we assumed this missing integer as x, we got x as 1. Let us write 369 divided by 1 is equal to 369. Now, let us see b bit. Minus 75 divided by dash is equal to minus 1. As usual, we will assume this missing integer as x. Minus 75 divided by x is equal to minus 1. Now, this x, when it goes to the right hand side, it becomes product with the number minus 1 as similar to this question. Now, we have to find x. So, this minus 1 comes to the LHS, that is minus 75 by minus 1 is equal to x. As this minus 1 is in product with x, when it comes to the left hand side, it gets divided by the number minus 75. Now, we have two minus signs in the numerator and denominator. When we will have two minus signs in numerator and denominator in division, they gets cancelled. So, we have 75 by 1, that is x is equal to 75. Let us write 75. Minus 75 divided by 75 is equal to minus 1. Now, let us see C bit. We have minus 206 divided by dash is equal to 1. We will assume this missing integer as x. Minus 206 divided by x is equal to 1. As you know, this x, when it goes to the right hand side, it gets multiplied. Minus 206 is equal to 1 into x. This one, when it comes to left hand side, it gets divided with the number minus 206. We have x on the right hand side. Minus 206 by 1 is minus 206. X is equal to minus 206. Let us write minus 206. Minus 206 divided by minus 206 is equal to 1. Now, let us see D bit. we have minus 87 divided by dash is equal to 87. Now, let us assume this missing integer as x. Minus 87 divided by x is equal to 87. As you know, this x, when it goes to the right hand side, it gets multiplied with the number 87. Now, we need to find x. So, this 87, when it comes to the left hand side, it gets divided with the number minus 87. That is minus 87 by 87. We have x on the right hand side. X. Now, 87 gets cancelled. We will get x is equal to minus 1 as we have minus here. So, let us write minus 1. Minus 87 divided by minus 1 is equal to 87. Now, let us see E bit. We have dash divided by 1 is equal to minus 87. We will assume this missing integer as x divided by 1 is equal to minus 87. Till now, we had dividend symbol for x. Now, we have this symbol for the number 1. So, let x be on the LHS is equal to minus 87. This dividend 1, when it goes to the right hand side, it gets multiplied with the number minus 87. So, minus 87 into 1. Now, x is equal to minus 87 into 1 minus 87. Let us write. Minus 87 divided by 1 is equal to minus 87. Now, let us see F bit. We have dash divided by 48 is equal to minus 1. We will assume this missing integer as x. Divided by 48 is equal to minus 1. Now, we have the dividend sign for the number 48. So, when it goes to the right hand side, minus 1 into 48. Right? X minus 1. When it goes to right hand side, it became into 48. Now, x is equal to minus 1 into 48 is minus 48. So, minus 48 divided by 48 is equal to minus 1. Now, let us see the last two bits in this question. G bit. We have 20 divided by dash is equal to minus 2. Let us assume this missing integer as x. 20 divided by x is equal to minus 2. Now, as you know, this x, when it goes from the left hand side to right hand side, it becomes into x. Now, this minus 2, when it goes from right hand side to left hand side, it gets divided with the number 20. 20 by minus 2 is equal to, we have x on the right hand side. 20 by minus 2. 2 ones are 2. 2 tens are 20. 10 by minus 1 is equal to x. 10 by 1 is 10. We have minus sign. So, x is equal to minus 10. 20 by minus 10 is equal to minus 2. Now, let us see h bit. We have dash divided by 4 is equal to minus 3. If you see, we will assume this missing integer as x divided by 4 is equal to minus 3. Now, we have dividend sign for 4. So, When it goes to the right hand side, it gets multiplied with the number minus 3. Right? Now x is equal to 4 3s are 12. We have minus sign, that is minus 12. Let us write. Minus 12 divided by 4 is equal to minus 3. Now let us see fourth question. Write 5 pairs of integers a comma b such that a divided by b is equal to minus 3. One such pair is 6 comma minus 2 because 6 divided by minus 2 is equal to minus 3. See, they asked to find 5 pairs of integers to satisfy this equation. That is, we will find 5 pairs. One example is already given. So, let us take a is equal to 12, b is equal to minus 4. Now, 12 by minus 4 is 4 ones are 4, 4 threes are 12. That is 3 by minus 1 is equal to minus 3. Right? Now, we will take this condition reverse. That is a is equal to minus 12 and b is equal to 4. Now, minus 12 by 4. 4 ones are 4. 4 threes are 12. That is minus 3 by 1 is equal to minus 3. Now, let us take third condition as yes. A is equal to 15. B is equal to minus 5. Now, we can write 15 by minus 5. 5 ones are 5. 5 threes are 15. That is 3 by minus 1 is equal to minus 3. Now, let us take the fourth condition as a is equal to minus 15. B is equal to 5. Now, minus 15 by 5. 5 ones are 5. 5 threes are 15. It is minus 3 by 1, that is equal to minus 3. Now, let us take the last condition, that is the fifth one. A is equal to 21. B is equal to minus 7. Now, we can write 21 by minus 7. 7 ones are 7. 7 threes are 21. That is 3 by minus 1. That is equal to minus 3. We have written all 5 pairs of integers. Those 5 pairs are 12 comma minus 4, minus 12 comma 4, 15 comma minus 5, minus 15 comma 5 and 21 comma minus 7.
GeopByte.